This is Simon Lague from Better Insect Solutions.
Okay. I need to put the microphone closer, do I? Because I saw the guy over there going, microphone, yeah, okay. Where are we? Sorry, whoops. Yeah, so my name's Simon Lague. I work for a company called Eno Plus, and we are part of the Big Dutchman Group. And about 2 years ago, the Big Dutchman Group, some of you may be familiar with them, decided to move into the insect business. As a back note to that, we've 50 years in animal farming. We have a lot of in-house knowledge about growing chickens and providing systems for chicken farming. And as I say, about 2 years ago, we decided to bring in-house knowledge on insects. Today, we are very much involved in developing systems. The goal is to create a turnkey approach to insect production, whether it's on a small scale or some of the bigger stuff that I'll talk about in a minute. We also do equipment testing and piloting on site. Yeah, so that's that. Most of the things I'll be talking about in the next 10 minutes is based on a project we're doing in Denmark. It's with a group called Enorm Technologies. And over the last year, we built a pilot site that was based on a space of around 3,200 square meters, producing 1.5 tons of larvae a day. The reason for this is, we wanted to understand how we could develop stable production of fly eggs and develop more knowledge about how we were scaling up. We've now dug ground to produce our first site. The intention is to run that at around 100 tons of larvae a day, and therefore around 36,000 metric tons a year. That sort of site we're seeing in conversation with others is probably kind of mid-size. We do go up to around 60,000 metric tons in terms of the design work we're doing at the moment. One of the other drivers, of course, because we're talking about sustainable production, is that, these sites have minimum environmental impact and make optimal use of the natural resources that are on site to minimize the carbon load on the planet. As a group, we don't do all of it. There are some parts of insect farm building that we aren't involved in, namely logistics in terms of crate management. So we work with companies like Viscon. And in terms of site construction, we also work with site builders. And we obviously have our own in-house capability with Agricon. But today, I'm going to focus mainly on climate, air cleaning, energy recovery, feed management, and Frass handling. So, insect production. Well, it's basically very similar to poultry production. Slight differences in any particular building. You're probably dealing with something like 10 to 15 poultry houses under the same roof. The production of heat and moisture in these cells that we build is significant. On a typical poultry farm, per square meter, we're talking about 250 watts, whereas on these sites, we're talking around 4 kilowatts. So that's a significant uplift in terms of air energy that we have to manage to get the best results out of the larvae, which in those terms means that we need to put more ventilation in, managing the heat, and adapt the systems that we have today to keep the humidity in the air energy under control. At the moment, on the substrate testing, if we base the kind of standard FCR around 1.5, we have achieved down to 1.05 with good climate management, but at the moment, typical trials are running around 1.3. Standard crate, which is 1 meter by 1.2 meter, we're producing up to about 11 kilograms of larvae per crate. So definitely climate has a big impact on the end result of the insect larvae growth. In terms of the environment and what we do in terms of emission reduction and as such the use of the energy from, to give you an idea, insect climate requires about 30 degrees, 28, 30 degrees temperature, and they run around 70 to 80% RH. So that's quite a lot of energy that we have to introduce into the house. A typical large-scale site, 60,000 tons a year, will require something like 12.6 megawatts of energy going in. So that's significant. But fortunately, we are using air scrubbers to clean the emission. And I apologize for this because I don't have an insect farm with this technology on, but you'll see here this is a pig house. And what we're doing here is we are drawing the air through an exhaust, running it into an air scrubber, and we're gathering the thermal energy of the house in the air scrubber and then transporting it through a heat exchanger system to a point where the energy can be used to precondition the building. So that has a significant impact on the carbon load in terms of energy to heat the houses. I will move on to the next slide and talk a little bit about feed, just aware of the time. What we've learned in the trials at the moment is that feed structure is critical. Okay, we're trying to create a substrate formula a bit akin to porridge. It can't be too dry, it can't be too wet, and that has significant impact on how the animals, how the insects perform in terms of production growth, but also in terms of the impact on the climate, which in itself has an impact on the animals. So, you know, an optimal feed program is basically working on feed quality, the effects of different types of feed, and when the insects want to use it. I won't go into the details on particular feed formulas because that's a subject in itself. Frass handling. Frass is a very valuable byproduct of insect production. It has various uses. We've been focusing a lot of work on how we can take the dried frass, pelletize it, and turn it into organic fertilizer. So, and I think in everything, in terms of European regulation on frass management, there is an issue of sanitization. We do deal with that within our systems. So I think that, you know, frass value really comes out of use in fertilizer. It can also be used as material to burn. For example, the BHSL system, which you may all be familiar with, use it to burn frass to create energy. There is also potential for biogas. The sanitization is expensive, and the legislation is developing on that, but we do see potential on that. Okay, if you want to learn a little bit about waste management and frass management, then there's the opportunity to go and speak to my colleagues on the NewQuip stand, because they are the ones who have the expertise in that field. And at the end, we have to bring it all together. Managing 0.5 billion animals in full production does take some effort, okay? And it's an interesting challenge. Today, the systems aren't really in place. They're not mature enough, but you know, we are developing those systems, not to the same extent that we have with poultry management. You know, certainly we haven't introduced AI yet. But where we stand today is you know, measuring larvae growth, kilos produced, the quality of the frass. Obviously, the climate's very important, and that is taking us to where we need to get to. But obviously, in the future, more in-depth knowledge of how the animals are reacting to production management will help us move that even further forward. So that's in short summary what an insect farm consists of. I think most of those areas will be familiar to all of you because it's not too dissimilar to poultry. But I suppose the question a lot of you are asking yourself is, you know, so can I get into insect production? And that's an interesting question. Today we have developed 2 trial systems that are being used for piloting for large-scale production. So we have a thing called a grow box. It's basically a containerized insect cell that can run nursery growth and also full production growth. And we also have what's called a feed box, which is we have the ability to replicate full-scale feed management programs on a smaller scale. These systems can be used on a farm to produce larvae for your, the use for your birds. However, to use it to replace soya at the moment probably is not viable. I mean, the cost is roughly 3 times what you're paying for soya. So then we get into discussion about, what is the minimum viable level that a poultry farmer could produce insects at. But this system, if we go from nursery, from the eggs to grow out, it's about 25 tons a year. And if we go from baby larvae, so in other words, if Thomas's company provides you with a baby larvae, then the grow out is 7 days, and you can produce around 50 tons a year based on this system. Okay. A little bit more on, being an insect farmer. As I said already, to swap out 50% of the soya, if you had a 100,000 bird farm, would require about 1 metric ton a day. But as I say, the cost of that is, around 900 euros a ton, as against around 300 for the soya. So it's significantly more expensive, and therefore, at this stage, probably not. In terms of diversifying, in Germany, we're working on a minimum viable concept, and we reckon there probably it'll come around to something around 2,000 tons a year of wet larvae will be the minimum viable model, and as such we will sell that as a concept where poultry farmers can get into the insect game, as it were, and make it a viable business. Processing, well, there's several options here. We can feed the live larvae to your birds, or process on site in a small unit and store to feed chickens at a greater scale, or sell on to feed companies, as an example. So that's just some options to think about. And in conclusion, as Thomas said, insect farming, what was it? No, Jake said, sorry, insect farming is happening now. Typical inquiries are coming from farmers saying, can I grow out my own insect protein, or can I diversify? And we are working on quite a few projects where farmers, for example, layer farmers, are no longer going to progress because of environmental restrictions, and they want to convert their layer houses into insect farms. That is very, very possible. Companies developing their own scalable insect production facilities. We're seeing a lot of companies that have been developing their own genetics and are looking for a scalable model that they can sell on to other companies. And then new market entrants, such as waste management companies, where obviously they want to find sustainable ways to deal with their waste. I put this in, the biggest development at the moment, as I've already mentioned, is probably around 60,000 metric tons, but of course that can go up. So that we would say is, currently big scale. And we expect, as also Jake said, was that, we expect the industry to grow significantly, probably 50 times where it stands today over the next 8 years. Key to this will be a turnkey solution, because that will allow us to reduce the risk of production. You can try and do it yourself. A DIY system can work, but there's so many variables and so many unknowns at the moment. Having a stable platform to develop insect genetics and insect production is key to reduce the risk to your business. And again, as Thomas said, we're on stand 37, so if you want to come and learn a little bit more, I've really scratched over the surface of this, come and learn a little bit more about how these systems work, then happy to talk to you there. Thank you very much.